Hello everyone, my name is Atish and I welcome you all in the third learning video on Euler's modified method. In the earlier classes we have seen the procedure to find out the solution of the given differential equations with the help of Euler modified method, and then very next to it we have taken a problem on Euler modified method. Okay. That was a simple problem. In today's class, we are going to take a problem on the same topic, but it is of some other type. Okay, because there are types of problems in the same topic. You may find it to be a easy one, or sometimes you may find it easy but lengthy, or sometimes you may find it a little bit time consuming, or what you can say a difficult one. Okay, but let me tell you, once you understand the thing, nothing is difficult for you. Okay, so let us start with the problem. So the problem says use Euler modified method to solve the equation this dy by dx is equal to x plus mod of y given y of 1 when x is equal to 0. So when we are learning it, y is equal to 1 when x is equal to 0 means this is nothing but the value of x0 and this is nothing but the value of y0. Okay, so this is x0 and this is y0. Let me write like this, one and the same thing. Okay, then for the range, now we have to get the solution of this given equation for the range 0 to 0.6, and we are having a step size of 0.2. Okay, so now as you can see, my initially I am at 0. Now I have to take a step size of 0.2 to reach 0.6. Okay, so how one can get? How many steps? One step is required to go from 0 to 0.2. Then second step will let me go to point number 0.4, and the third step will be there to get the solution for 0.6. So how many points are there? How many steps are there? So this problem required 3 steps to solve the problem. Okay, now suppose okay, I will take it at last because we should not get confused. So this method is a 3-step method. The problem that we have taken earlier, before that, that problem was a 2-step method. Okay, so that is the only thing. And earlier it was given directly that you have to find out y for this much of value. Okay, now instead of point, in the last problem what we have found out? We have found out y of 0.2. But here this doesn't want 0.2. This problem wants answer to each value of this x, which is lying from 0 to 0.6. Okay, so that is the difference we have. So let us start the solution of this problem. So as you can see that here, what is f of xy? My original equation is dy by dx is equal to f of xy. So here it is dy by dx is equal to something. So what is f of xy? Yes, f of xy is x plus mod of y. Okay, so I can write here, let f of xy is equal to x plus mod of under root of y. Okay, so this is given to us. Also we are given that x0 is 0, y0 is 1, and the step size is 0.2. Okay, so I will include that those things in step number 1. So let me write step 1. So in step 1, let me write down given. So we are given that what is x0? x0 is 0. What is y0? y0 is 1. And what is my step size in this problem? Step size is h is equal to 0.2. Okay, now as you know that with the help of these values we are going to find out the value of y1. Okay, and the value of y1 that we'll be getting, that is just the prediction that the solution for the initial solution would be something like that, then we have to take the approximate value to that, or we have to modify the answer given by y1. So you can write just by using Euler's formula, by using Euler's formula, what we have y1 is equal to y0 plus h f of x0 y0. What is y1? y1 we have to find out. What is y0? That's 1. What is h? h is 0.2. And what is f of x0 y0? x0 is 0, y0 is 1. So substitute here. So 0 plus under root 1, that is 1. So what value I am getting here? I am getting y1 to be, solve this, 1.02. This is the value I am getting for y1. Or if you want, you can write more systematically. Like this you can write, implies y1 is equal to 1.02. Okay, now this is the predicted value. Now we have to modify the value of y1 by taking the approximate values to this, and for that we need x1. Okay, so as x1 is equal to x0 plus h. What is x0? 0. What is h? 0.2. So this is 0.2. Okay, so the first answer that we are getting for 0.2. Okay, now let us find the approximate value. So if you want, you can write or in the sentence itself, the first approximate value is, or the modified first approximate value. First approximate value of y1, that is how we write the first approximate value of y1, y11, and which is given by, what is it, y0 plus h by 2 into f of x0 y0 plus f of x1 y1. Okay, whenever you are writing the formula, think twice about the formula, look it at again whether it is correct or not, because all these based on the formula. So if you write the incorrect formula, your calculations may be wrong. Okay, so now substitute y0, h by 2 and substitute all those values. So when you substitute all those values, what you'll be getting, if you want me to write all those things in detail, I can write like 1 plus what is h, 0.2 by 2, what is f of x0 y0, f of x0 y0 is 0 plus under root 1, that is 1, plus what is f of x1 y1, it is x1 which is 0.2 plus under root of 1.02. So if you want to get the feeling of that we are substituting the values, you can write 0 plus under root 1 plus here you can write x1 is 0.2 plus under root of 1.02. So because we are doing it for the first time, that's why I am writing, but okay, but you can directly substitute the values in the calculator and find it. So what value of y1 I am getting? The first approximated value of y1 comes out to be 1.2295. So this is nothing but the first approximated value. Okay, now you can write down the second approximate value. If you want, I can write it here, but I don't think so I will be getting that space. Okay, let me write here. Second approximate value of y1, that is y2, sorry, y12 is equal to, what is it? Let me write down this value a little bit. Okay, sorry. Okay, so what is the value of y12 then? It should be y0 plus h by 2, exactly same formula, only the last term will get changed, x0 y0 plus f of x1 y1 1. Okay, so we have this. So again you have to substitute the values and try to get the second approximate value after calculation. Okay, so it should be, let me write it here. So therefore y12 comes out to be 1.2308. This is the second value. Then again find out the third one. The third approximate value of y1, that is y13. Now you may be wondering why we are finding again value, because this and this does not agree, because the difference is not negligible. So that's why we are finding another value, say y13. So what is y13? y13 is y0 plus h by 2 into f of x0 y0 plus f of x1 y1. Okay, now substituting all these values, you will get y13 is equal to 1.2309. Okay, now as you can see, the difference between the last and this value is 0.001, but it is a good practice to get the values repeated. Okay, so let us find one more time. So what is the fourth approximate value? Fourth approximate value of y1, that is what is it? y14 is equal to, what you are going to write? One correction, it should be y12. Okay, so this is y0 plus h by 2 into f of x0 y0 plus f of x1 y13, correct. Okay, and this value comes out to be y14 comes out to be 1.2309. Okay, now as you can see, the value of y13 and the value y14, that is the third approximate value and the fourth approximate value of y1 agreed. So we can terminate the process. This is the value that we are getting. You can write at final answer like therefore, you can write therefore y1 is equal to 1.2309 when x is equal to 0.2. Okay, but we don't want just for 0.2, we want for point up to 6. So after 0.2, let us solve for the next step. Okay, so I am just going to change only few things. So here completes your step number 1. Now step 2. So in step 2, what would be Euler's formula? Just increment the suffixes by 1. So it should be y2, this should be y1, x1, y1. Okay. And for this we want, what we want? We want x we want x1. No, we already have x1. Okay, now substitute the values. So when you substitute these values, what you will be getting? When you substitute all these values, you will be getting y2 is equal to, what is y1? Yes, when you are finding the y2, then what value you have to consider? The last value, or this one and the same thing. Okay, the very last value you have to consider. So this is 1.2309 plus h 0.2 into f of x1 y1. So x1 is 0.2 and x1 is 0.2 and y1 is this. So when you solve this, you will be getting the value 1.4927. Just to save time, I am writing it like this. Okay, this is my y2. Now as you know that we have to repeat the process again and again. So the first approximate value of y2. So first approximate value of y2 will gives you the formula y1 h by 2 x1 y1 x2 y2. So y2 we have this is y2, x1 y1 we have. So what we need to find? X2. So what is x2? X2 is x0 plus 2h. So this is 2 times let me write here 2 times 0.2, so this comes out to be 0.4. Okay, so now let us substitute all these values and let me write it precisely now. So now you can just substitute and you can directly write the value of y21. So y21 comes out to be 1 point, let me check the value, 1.5240. 1.5240. Okay, so this is the value I am getting, the first approximate value for y2. Now you can go on finding the second approximate value, third approximate value if required. So y1, this is x1 y1 x2 y2. It's just a repetition, we are just changing the values. Okay, that is the best thing about the iterative method. We don't need to do or remember so many things, just follow the procedure. So y22 is 1.5252. Then find out the third approximate value of y2. So third approximate value of y2 is y23, which is given by x1 y1 x2 y2 2. This is important. Okay, so value of y23 is 1.5253. This is y23. Okay, now if you want you can stop here, because just the difference is very negligible, but if you you are not getting the feeling of that happiness that we are actually getting the answer, so you can just go on finding the values. So like this is y24 and here it is y1. So y1 plus h by 2, this is x1, this is y1, this is x2, this is y2, and the answer is 1.5253. 1.5253. So you have to write down the final answer. So the value of y2 is 1.5253 at x is equal to 0.4. Okay, now this is not completed yet. We have to again repeat the same process by changing for x3. Okay, so again for step number 3 we have the formula y3 is equal to y2 plus h x2 y2. Then substitute those values to get The answer 1.8523. Let me check the answer. Yes, it is 1.8523. Okay, now in the first approximate value of y3 needs x3, because it is y31 given by y2 plus h by 2 f of, now here it is x2 y2 and here it is x3 y3. Okay, now substitute these values. Now to get this value we need x3, so that is why I am doing the calculations. I am finding this. So what is x3? Do you remember? x3 is x0 plus 3h. So 3 times this 0.6. So we'll get the final answer for 0.6. Okay. So what values we are getting? We are getting 1.8860. 1.8860. Okay. Now again we have to, because process will not terminate at first approximate value, so at least we'll be having at least 2 approximate value, and depending on the problem it may increase. So second approximate value of y3, which is given by y32, so this is y2 plus h by 2 f of x2 y2, and then here it is x3 and here it is y31, okay, which is this value. So substitute this value to get y32, and y32 comes out to be 1.8861. 1.8861. Then find out the third approximate value of y3. So the third approximate value of y3 is given by y2 h by 2 f of x2 y2 x3 y3. Okay, rest of the thing is same. So y3 comes out to be 1.8861. Okay, so in the earlier steps we need to find out the fourth approximate value, but in the third one we get the values, repeated value at what? We get the repeated value at third approximation. Okay, so at last don't forget to write down your final answer. Just write therefore y is equal to 1.8861 when x is equal to 0.6. So this is the final answer. Okay, so this completes this problem. So I hope you got an idea that how to solve, and you just need to, if you have concentrated on this the procedure, so you might have pointed out one thing, only this thing is changing in every formula. In the first approximation it is y3, sorry, yes, it is y3. Okay, and in the next formula, throughout the formula is same. In place of y3 it is y31. Okay, rest is as it is formula. Right hand side, left hand side will change. In the next formula this get changed. Okay, so this only the change of this term is there, the formula is as it is. Okay, so I hope this is making sense, and you can solve problems based on this topic, very important topic. And thank you for watching this learning video. Enjoy learning mathematics. Thank you.